Polar versus non-polar, which dissolves better. Did you know water doesn't always dissolve everything? It's a 5 minutes approach about fact finding. Let's throw in today's 5 minutes chemistry breakdown. We shall uncover the truth behind polar versus non-polar molecules and ask the burning question: which dissolves better? Is the like dissolves like rule always correct, or is there more to the story? So stay tuned as we break down intermolecular forces and solubilities like never before. Polar and non-polar molecules, here is the introduction. Let's start by addressing a common misconception. Oil and water don't mix, right? Well, the truth is more complicated. Polar molecules like water have an unequal distribution of charge, which means they can form hydrogen bonds, but that doesn't mean that they can dissolve everything. Non-polar molecules such as oil don't have this charge difference and instead rely on weaker forces like dispersion forces. But does that mean they are less useful in the world of dissolving substances? Let's find out. The science of solubility here is like dissolves like. Here is the big question: does like dissolves like always hold up in every situation? For example, polar molecules like water dissolve salt really well. The positive and negative ions in salt interact with the charged parts of the water, breaking it completely. So here is the crystal lattice of the sodium chloride. Here is the perfect arrangement of the ions, that is Na positive and Cl negative in a crystal lattice. Here salt, when it is poured into the water, salt is dissolved in water and the ions are liberated from the crystal lattice into the water molecules. But there is the twist. Non-polar molecules like oil don't dissolve in polar solvents like water. However, they do dissolve perfectly in other non-polar solvents. So the solubility rule is not as simple as it seems. Now let's talk about some real-world examples that might surprise you. Water and salt. When you add salt to the water, it dissolves thanks to the polar nature of the both substances interacting. But oil and water, that is the different story. While oil is non-polar, water is polar, and their interaction is weak. This is why oil doesn't mix with water. Isn't not a myth, it's a science. Here the dissolution of the oil with water, actually oil and water did not dissolve into each other. You can see here the separation of the oil droplets on the surface of the water. You can see in this video. Here is the intermolecular forces acting between the polar and non-polar or otherwise polar and polar molecules. So why do polar molecules behave so differently from non-polar molecules? It's all about their intermolecular forces. Hydrogen bonds have polarity. So the polar molecules like water form hydrogen bonds, which are strong interactions between the positive and negative poles, allowing them to dissolve other polar substances to each other. But non-polar molecules like oil rely on weaker dispersion forces, making them great at dissolving other non-polar substances, but not so much with polar substances. Now the solubility debate. Here is the controversial part. Can water really dissolve everything? The short answer is no. While water is known as the universal solvent, it's not capable of dissolving all substances. For example, oil and water would not mix due to their vastly different polarity. In fact, It is the intermolecular forces between molecules that determine solubility. And it's not as simple as just saying like dissolves like. Sometimes polar versus non-polar interactions can surprise us. Understanding the fact how polar and non-polar molecules behave is crucial for so many industries. Here is the cleaning. Ever wonder why dish soap works so well to clean grease? So molecules like both polar and non-polar ends, which allows them to interact with both oil and water, breaking up those greasy stains. On the other hand, medicine. Many medications are designed to dissolve in either polar or non-polar solvents so they can be absorbed by the body. In environmental sciences, here is the application to environmental science as oil spills. Oil spills are another example where non-polar and polar molecules interact with each other. Here, they are causing dangerous contamination. So, we are at conclusion. So, which dissolve better? The answer depends on the solvent you choose. Polar dissolves polar and non-polar dissolves non-polar. But remember, solubility is not always predictable, and not all the substances follow the simple rule of like dissolves like. Now you know why oil and water don't mix. It's all about intermolecular forces. Got more questions about solubility or chemistry concepts? So drop them in the comments below. Don't forget to like, subscribe and share this video with your friends who want to understand intermolecular forces and solubility better. See you in the next video.